Hello, everyone, and welcome back. My name is Mr. Cobalt, and in this video, I'm going to talk to you about the relationship between masses of elements and compounds. So let's get into this. So in this video, I'm going to really focus on the conversion between masses of elements to masses of compounds, or masses of compounds to elements. And so we're going to need a strategy to use, and here it is on the board. Now, I'm going to say this, and I always say this in my videos, when it comes to converting between one substance and getting a different substance, no matter what that substance is, if you're going from one substance to a different substance, you're going to need to use a mole ratio or use a ratio of moles between the two substances. That's the only way you're going to be able to convert from one substance to the other. Well, I shouldn't say the only way, but it is the by far the most common way of converting from one substance directly into another substance. So the roadmap that you're going to want to use is this general roadmap right here. I'll talk about this one in a moment, which is a little bit more specific, but here's the general roadmap. You want to make 3 steps. Step number 1 is you need to, whatever property you're given, whatever measurable property you're given, whatever unit you're given, you want to convert that measurable property to moles. That's your first step. Whatever you're given, get it to moles. That's step 1. So step 1, get your substance, whatever the measurable property they give you, get it to moles. Once you have moles of substance number 1 that you are starting with, you can now convert that to moles of substance number 2. And then step 3, once you got moles of substance number 2, then you're going to convert that to some other measurable property that the problem wants, right? So if I'm going to write this down, so this would be step 1, step 2, step 3. And each of these steps is going to be done through conversion factors. Okay, so in order to go from one step to the next, you've got to have a conversion factor that you can convert units from one unit to another. Now, here is a more specific roadmap, if you will, but the 3 steps are still there. So grams is by far the most common unit that you're going to be given or that you want to get to. So if you start with mass, normally you're given mass of one substance and then you want to convert to mass of a different substance. So the steps are the same. So let's say you're given units of mass of one substance. Well, if that is not already in grams, you need to convert it to grams, right? So let's say you're given kilograms. You would need to convert kilograms to grams using the conversion factor of 1 kilogram is equal to 1,000 grams. Once you get to grams, then you're going to convert to moles, and then the conversion factor there is going to be molar mass, right? So you're going to use molar mass here to convert from grams to moles of the first substance. And then you're done with step 1. So you're going from whatever the given unit is, convert it to moles. Sorry about that. Okay, so then once you got moles, then in step 2, you're going to convert moles of the first substance to moles of the second substance. And there you're going to need a mole ratio. So here, you're going to use a mole ratio to convert from moles of one substance to moles of the other substance. And then where are you going to get that mole ratio? Well, there's a couple of places you can get that. The one place that we're going to be talking about in this video and focusing on this video is the formula, right? Because here, as the title says, we want to look at the relationship between the masses of elements and their compounds. And they're the element to the compound. If we're converting between elements and the compound of which the element is a part, then that's going to be the formula. The formula of the compound gives you the mole ratio between the compound and the element in the compound. Okay, so that's where the mole ratio is going to come from. So that'll be like the formula of the ratio in the formula. I'll show an example of that in a moment. Once you get the moles of your substance number 2, whatever that is, then the step 3 is converting to whatever desired unit they're asking for. So you would, if that's a mass unit like kilograms, if I want to know the kilograms of substance number 2, then I'll have to use molar mass here of substance 2. So the molar mass of substance 2 is used to convert from moles to grams. And then I use moles, I use the same rate relationship. So if I want kilograms to convert grams to kilograms, I use 1 kilogram is equal to 1,000 grams as a conversion factor to convert back to kilograms. And so this is the general 3-step problem. So again, just to summarize, whenever you're converting from one substance to a different substance, step 1, whatever unit they give you, whatever measurable property they give you, you're going to convert that to moles using whatever conversion factors you can use. Once you got the moles of substance number 1, you're then going to convert that to moles of substance number 2 using a mole ratio between the two substances. That mole ratio can either come from the formula, which we're talking about in this video, or if you're doing stoichiometry, it's going to come from a balanced chemical equation. Okay, that's step 2. Step 3, once you have moles of your substance number 2, you're going to use conversion factors to get to whatever the desired unit that they want you to get to. Okay, and that's step 3. So the 3 general steps. So let's do an example that I can show you so it's clear what I'm talking about. So let's say they give me 23 kilograms of C6H14. So here I have hexane. So I have 23 kilograms of hexane, but they want to know how many kilograms of carbon can I get from 23 kilograms of hexane. So I'm going from mass of one substance to mass of a different substance, carbon. Now notice the carbon is part of the compound that I am talking about. So to convert from this to this, I'm going to need the mole ratio between hexane and carbon, and you get that mole ratio from the formula. So here I can see that for every 1 molecule of hexane, I have 6 atoms of carbon. So the mole ratio is 1 to 6, because for every 1 mole of hexane molecules, and I know each molecule has 6 atoms, that means 6 moles of carbon is gotten from 1 mole of the hexane. So the ratio is 1 to 6. So I can use that mole ratio as a conversion factor through my steps. So I'm gonna write it out, but I'm not gonna solve it. I just want to show you how this is set up according to the steps. So I start with 23 kilograms of the hexane, C6H14. So step number 1, I have kilograms. I need to get to moles. That's my first goal, right? So again, step one, get to moles. Moles of my first substance. So whatever unit I'm given, I gotta convert that to moles in some way, shape, or form. So since I'm given kilograms, I can't convert this directly to gram or to moles, but I can convert this to grams. And if I have grams, I can now use the molar mass of hexane to convert the grams of hexane to moles of hexane. So then I can do that. So then I know that one, excuse me, I know that 1 kilogram is equal to 1,000 grams. I have kilograms on top, so I'm going to put 1 kilogram of hexane on the bottom and 1,000 grams of hexane on top. Oops, that should be a 14. That was benzene. There's hexane, so there's 14. So now the kilograms of hexane cancel out. Now I have grams. So now I've got grams. Now I can go to moles using the molar mass. So what's the molar mass of hexane? Let me look it up. It's about 86.18. So the molar mass of hexane is 86.18 grams is equal to 1 mole of hexane. Since I have grams of hexane on the top, I'm going to put the 86.18 grams of hexane on the bottom, and then I'm going to put 1 mole of the hexane on top. So now grams cancel out. Now I have moles, which is what I want. Now I got the first step done. So I've gotten my kilograms of hexane, which is substance number 1. That's what I'm beginning with, and I've gotten it to moles. Now I can use the mole ratio. Again, where am I going to get the mole ratio? From the formula. So anytime you are converting from an element in the formula to the compound, or from the compound to an element in the formula, the mole ratio in the formula is what you're going to be using. So here I know that 1 mole of hexane gives me 6 moles of carbon, so I'm going to use that mole ratio. So then I'm going to use that as a conversion factor. So 1 mole of the hexane is on bottom because I want to cancel out with top. And then 6 moles of carbon on the top. So there's my mole ratio. And again, it comes directly from the formula. For every one of these, I have 6 carbons. So it's 1 to 6 ratio. So moles of hexane cancel out. Now I have moles of carbon. I'm done with step 2. I've got my moles of substance 2. In this case, substance 2 is carbon. And now step 3, I want to convert to the desired unit. The desired unit in this case is kilograms of carbon. But I got moles. So now I have to convert to kilograms. In order to get to kilograms, I need to convert to grams first. So I'm going to convert moles to grams using the molar mass of carbon. So I'm going to put moles on the bottom. So 1 mole of carbon on the bottom and 12.011 grams of carbon on top. That's the molar mass of carbon. Moles of carbon cancel out. Now I have grams of carbon. So my last step is to convert grams to kilograms. And so I know that 1 kilogram is 1,000 grams. I have grams on top, so I'm going to put grams on the bottom here. So 1,000 grams of carbon on the bottom and 1 kilogram of carbon on top. So grams of carbon cancel out. Now I have kilograms of carbon. I've got the unit I want, which is kilograms of carbon, so I am done. So I've followed the steps, and here they are in conversion factor form, right? So now, in order to calculate the number of kilograms of carbon that come from 23 kilograms of hexane, all I need to do is multiply by everything on the top, divide by everything on the bottom, and I get my answer. And then that's it. So I'm not going to calculate this out. I just wanted to show you the method and how I follow the steps. So again, just to recapitulate what was talked about in the video, follow these 3 basic steps. Whenever you're going from one substance to another, the 3 basic steps is whatever unit they give you, convert that to moles. That's step 1. Step 2, once you get to moles of that first substance they give you, convert that to moles of the second substance using a mole ratio between the 2 substances. Again, that mole ratio is going to come from the formula. If we're going between elements and compounds, it's in the formula. The ratio in the formula is your mole ratio. If you have a balanced equation, then the mole ratio is going to come from the balanced equation. Okay? That's step 2. And then the third and final step is once you've got moles of substance 2, you got to use your conversion factors to get to whatever the desired unit they want, right? In this case, it was kilograms. It could be liters. It could be milligrams. It could be micrograms, whatever. Just use whatever conversion factors you can to get to that desired unit from moles, okay? That's it for this video. I hope this was helpful. If you like this video, if this helped you in any way, then please, by all means, like the video. Hit that like button. Share the video with your friends. Share it abroad. Share it on the internet. Share it in whatever groups you have. Also, make sure that you subscribe to my channel. Hit that notification bell. When you do, make sure you click all so you can be notified by all the videos I put out. And then finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a topic you want me to cover, if you have a question or a problem you want me to help you with, put that down below in the comment section. I would love to help you with that. Thanks for joining me and have a great day.